This video is on Unit 2, Chapter 5, Lesson number 3. In this lesson, solving quadratics by square roots, we're still focusing solving quadratics, but we're going to be using the square root property. So solving quadratics by square roots, in your notes here, it says quadratic equations of the form ax squared plus c is equal to 0 can be solved using the square root property. And the square root property says if x squared is equal to n, then x is equal to the positive and negative square root of n. Now, I'm going to back up for just a second. Back up here where it says quadratic equations of the form. So I have a little asterisk here out to the side. There's no bx here. Ax squared plus c is equal to 0 is missing the middle term, the bx term. In that situation, you're going to use your square root property to solve. The square root property basically means that if you've got x squared is equal to n, the opposite operation of squaring a number is square rooting the number. So when we square root both sides of an equation, we get x is equal to the square root of n. But because it's an equation, technically there is a positive root and a negative root. So let's go through here and I'll explain once we get through with an example. The steps tell us to isolate the x squared. Secondly, take the square root of both sides. And then thirdly, simplify the radical, place a plus or a minus to indicate both answers. So in example number 1, we've got x squared minus 64 is equal to 0. To isolate the x squared term, we've got to get rid of this minus 64. The opposite of minus 64 is add 64. So what we want to do is add 64 to both sides. And we get x squared is equal to 0 plus 64 is 64. Now at this point right here, the opposite of x squared is square root. So we're going to square root both sides of this equation and we get x equals, the square root of 64 is an 8. And we're going to do the positive and the negative 8 to indicate that both of those answers will work. And here's why. If I go back to the original, x squared minus 64 is equal to 0, and you plug in the 8 squared minus 64 equals 0. 8 squared is 64. 64 minus 64 is 0. So that checks out. If you plug in the negative 8, the same thing is going to happen. Negative 8 squared is a positive 64. 64 minus 64 is still 0. So both of those work, the positive root and the negative root. All right, let's look at number 3. We've got 81x squared plus 5 is equal to 21. Again, the first step is to isolate the x squared. So I'm going to subtract the 5. Because it's a plus 5, remember we need to do the opposite and subtract. So we get 81x squared is equal to 21 minus 5 is going to be 16. Then we're going to divide both sides by the 81. Remember, you're supposed to get the x squared by itself. Now, 16 divided by 81 does not simplify. And you've got this ugly looking fraction, fear not. Take the square root of both sides. So we get x equals positive and negative. 16 and 81 are both perfect squares. The square root of 16 is 4. The square root of 81 is 9. So we get a positive and a negative 4/9. So the steps for square root property are the same over and over and over again. Things are going to get a little more difficult as we go. Let's look at number 5. We've got 2x squared minus 9 is equal to 55. So again, step number 1 is to get the x squared by itself. So I'm going to get rid of the minus 9. The opposite of minusing a 9 is adding a 9. And we're going to add that to the 55. 55 plus 9 is 64. And then we still need to divide by the 2 before we can square root both sides. We get x squared is equal to 64 divided by 2 is 32. Now, when we square root both sides on this one, 32 is not a perfect square. So we get a positive and negative square root of 32. We have to simplify that radical. Notice up here in the steps, it says, step number 3, simplify the radical. So we got to simplify the square root of 32. Going back to the very first lesson of chapter 4, I showed you how to do that in the calculator. So you're going to go to y equal, put the 32 divided by x squared, go to your table, and it looks like we have 4 times the square root of 2. So it'll be a positive and a negative 4 times the square root of 2, and that's my answer for number 5. Let's jump down to number 9. Number 9 says negative 1/2 x squared plus 1 is equal to 39. Again, we got to get the x squared term by itself. So I'm going to subtract the 1. Because it's a plus 1, again, you got to do the opposite and subtract. So negative 1/2 x squared equals negative 39 minus 1 is a negative 40. From here, most of you are probably going to divide both sides by the negative 1/2, which is fine. I'm going to multiply by 2. Actually, I'm going to make that a negative 2. If you multiply both sides by negative 2, a negative times a negative makes that a positive, and then the 2's themselves are going to cancel. So I get my x squared is equal to negative 40 times negative 2 is a positive 80. And then the next step, of course, is to take the square root of both sides. We get x equals a positive and a negative. We have to simplify the square root of 80. So 80 divided by x squared gives us, should be 4 times the square root of 5. And there's your answer for number 9. All right, let's jump over to the next page here. And let's look at number 10. X squared plus 81 is equal to 0. Now you'll notice here on the left, it says solving quadratics by square roots, imaginary solutions. So in this section, I'm introducing you to the imaginary solutions, meaning this would be a parabola that doesn't actually come down and hit the x-axis. You have imaginary solutions here. Steps are the same. Isolate the x squared. Get rid of that plus 81 by doing the opposite and subtracting 81. So x squared equals negative 81. When we square root both sides, x equals a positive and a negative. And the square root of negative 81, the negative underneath the radical means you have an I. 81 is a perfect square, and it's 9i. So we have a positive and a negative 9i for our 2 solutions on number 10. Y'all remember that is a positive 9i and a negative 9i. And I choose to write it as 1 with the plus and the minus in front. If you want to separate them, that's fine too. Just make sure you do understand that those are 2 separate answers. All right, let's look at number 13. Number 13 says x squared plus 13 is equal to 1. Again, isolate the x squared term. We're going to get rid of that plus 13 by doing the opposite and minusing 13. And we get x squared is equal to 1 minus 13 is a negative 12. And then we've got to square root both sides. So x equals a positive and a negative. You have an I and the radical 12. And you have to, again, simplify the 12. That square root of 12 should simplify to 2 radical 3, and it does. There it is. So I have a positive and a negative, 2 and a radical 3. Don't forget where the I goes. Now your plus minus is going to go in front of that. And then the I goes behind the 2. All right, let's look at number 14. 3x squared minus 5 equals negative 446. Again, you got to get the x squared by itself. Get rid of the minus 5 by doing the opposite and plussing 5 to the negative 446. So 3x squared is equal to negative 446 plus 5 is going to be a negative 441. And then we're going to divide both sides by the 3. And that gives us x squared is equal to, when you take negative 441 and divide by 3, oops, wrong screen. Negative 441 divided by 3, you get negative 147. From here, again, you're going to do the opposite of x squared, and you're going to square root, and that gives us our x equals plus and a minus. I'm going to go ahead and take care of the negative, which is my I, and then I'm going to go to my y equal and do 147 divided by x squared. And I'm thinking that's the 7 and the 3 there towards the bottom. We can scroll down so you can for sure see, yes, it is 7 times the square root of 3. So it's 7i square root of 3. So those are your notes for this lesson. Lesson number 3 in chapter 5. Again, we'll work on the assignment in class.